Hi, welcome to Weka. At Weka, we're passionate about performance, and today I want to share with you some of the great results that we recently set on STAC M.3 benchmark for time series database. But first, let's talk a little bit about the financial space. So today, we see that somewhere between 80 to 90% of all trading is done using technical trading. And the real enemy of the technical trading space is latency. And what we find typically in the environments where people care about latency and care about how fast they can make their trade is they often resort to using local file systems or a SAN to execute on their trades. Now the challenge with this is, and I'm going to show you here diagrammatically, if you take a workload and put it into your SAN, and you have another one running on local storage, what happens with your users is you now start to see that they start to build up behind while they're waiting for those local machines to execute. Now, the machine might be fast, but the time that you actually spend waiting to get in queue to get that machine is often where the real latency comes in, because it all adds up to wall clock time. And what wall clock time means is how long it is between when you want to trade and when you can. At Weka, we're passionate about removing latency from the systems. And first of all, let's talk a little bit about what we've built. We've built a scalable NVMe-based high-performance storage. So from a media perspective, it's as fast as you can get. And we have a shared file system with cache coherency of direct attach or SAN. So we allow you to have this environment where you can effectively act like a local file system when you need it. But if that same file is being shared by others, we ensure that there's coherency in that file and that you're always working with the most recent and most up-to-date files. We effortlessly present petascale data to your applications, and we fully saturate compute resources for great efficiency. We also seamlessly handle large and small files because the way our software works is any large file, we break into small files. So every file is a small file problem from the Weka perspective, and we handle those beautifully. We also are fully cloud enabled for hybrid or public cloud deployments. So if you do need elasticity in your environment, we can handle that too. Last but not least, and a really great part about our product is we fully integrate disk-based object storage as a data lake as part of our software and present it all as one seamless layer. And we move data back and forth between the hot tier and the cooler tier and allow your applications always to have full access to the data sets without ever having to actually migrate data from one system to the other. We take care of that internally and transparently to you. So the real things that you get with Weka are fast wall clock times and a system that's much simpler to manage at scale because you're not dealing with all of those users waiting in queues and having to wait for their machines to come free. We also have no performance tuning required for the product. It really is simply, once you set it up, it's once and done. The other thing that's great is we lower your overall cost of infrastructure because we make your server infrastructure a lot more efficient. You get a lot more utilization of it because you're not having to wait for users to copy data in, scrub that data set, and then get the next workload in. And the other thing we allow you to do is you don't have to have local storage inside those servers anymore because we can provide you a shared storage environment that, as I'll show you later, can be as fast or faster than you can get with direct attach. And the other thing is we give the ability to run more on-demand models because we allow you to seamlessly integrate with the cloud as well. And I wanted to show you this here. We always make a claim that we're the world's fastest file system, and this was validated by this IO 500 group at Supercomputing 2019, where Weka IO running on the public cloud was actually faster than an Optane-based system from Intel. This is what we typically look like in production. You have a bunch of GPU nodes, or it could be CPU-based nodes running a KX KDB+. And we have a cluster of storage appliances that are based on any of the standard server vendors from any of the major vendors. We have reference architectures with all of them. Our software is layered on those storage nodes with local SSD, and we present a global namespace to your application that can continue to scale out as you add more nodes. Internally, if you want to, and by the way, this is something you can do on day one or later, we allow you to tier seamlessly to an object storage. and you can expand your data lake. And in fact, that data lake can also expand into the public cloud. So it's very versatile in terms of our ability to be able to scale out to exabytes of storage with absolutely no loss in performance. And I'd like to share with you some of our customer successes. We have a quantitative trader whose problem was they needed direct attach performance, but kept burning out their local server NVMe drives, as an example of that local storage example I gave you earlier. With the Weka file system, they've proven to be 3 times faster than direct attach, and it scales effortlessly. And much of that performance improvement came from the fact that they have overall wall clock time has reduced, as opposed to just how fast the data is running locally inside the server. The second one is a quantitative trader using KDB+, and they wanted to move to AWS, but could not find a solution that was performant enough. With Weka on AWS, they provide higher performance than on premises, and they also have provided a very easy test dev environment because they can make a clone of their data, and they can now run the new workloads against that and test out new models that they have, for example. So it gives them both a test dev environment that they can run against production data while not impeding on the actual performance tier. The third one is a major bank, and they had purchased a single very expensive scale-up KDB Plus server. And the problem they had was everybody was waiting in a queue. So it was a nightmare to actually manage this environment. And in fact, we jokingly say the latency in this case didn't come from the actual infrastructure. It came from the guys hanging around waiting for their models to run. With Weka file system, they enable scale out of the KDB Plus time series analysis, and they've had much better use of their infrastructure. And they've also been able to purchase much lower cost servers because now they don't need those servers to have all that memory and storage locally. They can run it directly off the Weka storage system. So now I'd like to talk a little bit about STAC M3 and the benchmark records we set. First of all, what is STAC? So if you're not familiar, it's independently audited tests for the financial market use cases that use a time series database. In the case of KDB Plus and the STAC M3, they have a 1-year data set, which is on Tuco, which you very often find direct attached server vendors run because they can fit that data set in their, inside their direct attached server. But now when you scale out to 5 years of data sets, it's called Kanaga, and typically that's the one that represents much more effectively how a shared storage system can do, because you need a lot more data that can necessarily fit inside one system. What we will show is we set records on both Antuco and Kanaga. And the other thing about it, the test, is it varies the number of clients to test concurrency. So it'll test from 1 client all the way to 100 clients. And what this really shows is putting more and more load on the actual IO and the storage system really represents typical environments that you find in larger institutions. And this is very typical of what we find with our customers, where it's not just 1 client and 1 set of data, it's many, many clients that need to access that data. The other key thing to note is that it is a very read-intensive environment because you're looking at a time series database from past historical events. And so very representative of how well read performance does. If you'd like to learn more about STAC M3 benchmark, I have a blog at weka.io called What is STAC M3 Benchmark and Why You Should Care. Very well worthwhile reading if you'd like to learn more about the benchmark itself. So what did Weka set on this STAC M3 testing? Well, first is we set 17 new records. And what was great about it is we actually beat all of our own prior records that we set in 2019, which was 11. And some of them we beat by up to 2x. And this is improvements that we've continued to make in our software, particularly around read performance, which is a use case we find very much in machine learning, in AI workloads, in deep learning workloads, and also in financial use cases. We also did a clean sweep of all the STAC M3 benchmarks that record bandwidth. And again, this is because in read-intensive environments, it's a bandwidth and I/O intensive, and it really highlights the amazing performance improvements we've had in our software. So first, let's look at the system. We did this in conjunction with HPE, and we also did it in conjunction with KX Systems, KDB Plus 3.6. We had 14 HPE ProLine Gen 10 servers for the database servers, and 18 of the ProLine Gen 10 servers for the storage cluster. So same storage nodes and database nodes were the same. These are very baseline systems. Minimum memory was only 96 gigs of memory. We actually normally even recommend 192, so it was below our normal standards. It was the WekaFS 3.62 software, which we released earlier this year, and obviously running on Mellanox, which we love the Mellanox technology for their great performance. And this was in an InfiniBand environment. And you can find the full STAC report as well on the STAC site. The key thing we did is we outperformed all publicly disclosed benchmarks in 11 of the 24 Kanaga mean time response, and all 11 of them had a read-intensive performance use case to them. The other thing you'll notice is, particularly when the benchmarks had high user multi-client, we did very well. We also outperformed all publicly disclosed results on 5 of the 5 Kanaga throughput benchmarks that I talked about earlier. So now let's look at ourselves compared to other solutions. We did a number of comparisons. First, we looked at ourselves versus an all-flash NAS. We are an all-flash scale-out NAS parallel file system, so that was comparable to the all-flash NAS. And you can see on all 24 benchmarks on Kanaga, Weka was faster. So this is a key thing to notice, is that we beat all 24 benchmark results. The other thing to note is we compared ourselves to a direct attach Intel Optane-based flash using 3D NAND flash SSD. So again, this is a single scale-up machine, direct attach. And again, on 19 of the 24 Kanaga benchmarks, Weka was faster. The third comparison we did was comparing Weka to a KDB Plus solution running on a fiber channel SAN. So typically for people that can't get all of their data inside of a Optane direct attach system, the next option that they typically look to is a SAN-based solution. And again, even on the SAN-based solution on 12 of the 24 Kanaga benchmarks, Weka was faster than an all-flash SAN. So you can see even NVMe over Fabrics, Weka is still able to outperform a SAN-based solution. So here's a look at the data from another perspective on a performance benchmark. We look at 100 clients, and this is for Antuco. So this is just the single year event. This is actually the easier of the two in terms of the Antuco benchmark doesn't stress as much from the point of view of a number of years of data. And it's very often, as I mentioned before, what people run when they're running direct attached servers, because it can show off your single server. You can see that on 100 client where we loaded up and put a high concurrency in that system, that Weka outperformed the all-flash array. We outperformed the all-flash NAS by over 3x, and we also outperformed the SSD-based direct attach server. So again, on Antuco alone, we had a record. Now, if you look at Kanaga, so on the Kanaga front, you're really scaling out on two fronts. You're scaling out on the number of clients, and you're scaling out on the number of years. And now you can start to see a huge differential between Weka and the other systems. So we were 2 times faster than the all-flash array for 100 clients concurrently running against the system. And against the all-flash NAS, we were 4.5 times faster than the all-flash NAS with 100 clients on a 12-day run. And against the Optane direct attached server, you can see that this is a very, very difficult for the Optane-based server to finish on 100 clients. So it really is not a suitable environment when you have high concurrency and a high amount of data sets. So what we show you is that WekaFS gives users the ability to scale to high concurrency for small and large data sets. So last but not least, I'd like to now show you it over a time series of the 5 years. And you can see as the increasing load from 1 to 2 to 3 to 4, 5 years, Weka maintains the best performance characteristic of all of the solutions, whether it's a SAN, an all-flash NAS, or a direct attached storage. And if you look at this diagram, you really should be comparing Weka to this line here. This is the other all-flash NAS. And you can see Weka is down here below what is the performance results for the SAN and also the direct attached server. So in essence, another way to look at this is we're proving that a shared file system can deliver better than what was previously only possible with direct attach or SAN. So for Weka, what we really believe our value to you is shared data set, very, very low latency, very high performance, and the ability to be able to scale out your environment very simply, share your data with lots of users, and really save on your compute infrastructure because you don't have to load up those compute nodes anymore with expensive NVMe-based technology just so you can copy the data in and run it faster. So thank you, and I appreciate the time you've spent listening to our little presentation here. And for more information, please go to www.weka.io and go to our blog posts to learn more about the great Weka system. Or if you're a member of STAC, we recommend that you download the benchmark results we've shown you and compare them to the other systems that are out there. Thank you.